Yo, check this out. We're going to be adding two linked lists together. This is kind of tricky because linked lists go from left to right, but they want us to add from right to left. So how do we solve this problem? Well, I'm going to show you right now. Let's hop into it. So here we have two linked lists, 7243 and then 564, and we're just going to add vertically starting on the right hand side and progressing to the left. So I have 3 plus 4 equals 7, 4 plus 6 equals 10, so we put a 0 here, we carry the 1, now it's 1 plus 2 plus 5 equals 8, and so on. So that is the problem. The little trick here is that linked lists are going to start from the left to the right. It's going to have a next pointer. So this is what makes this problem challenging because we're adding on the right hand side, but we actually start on the left hand side. So how do we remedy this? Well, the first thing we can do is just reverse it and then use the same logic we used in add numbers 1. Add two numbers 1, I should say. So let's make a function to reverse our linked list and then return the head. So what I'm going to do is just say const reverse list. I'm going to pass in a node, and then I'm just going to do the traditional logic to reverse a linked list. If you want to see this in another video, I've uploaded other videos. So I'm not really going to focus too much on this. I'm just going to quickly do it, and then let's get into it. So I'll say let cur equal head, let prev equal null. While cur is truthy, I need to capture the value of the next pointer for cur. So I'll say let next equal cur.next rather. Then I need to adjust the pointers for the prev node. So I'll say cur.next equal the previous node. And then prev, we're going to move that up to the cur node. And then cur is going to equal the next pointer I stored here. Next, and then as you know, in a reverse linked list, we're going to return that previous value. So this is going to reverse our linked list. So now let's make some new variables. L1 reverse is going to equal reverse list L1, and then L2 reverse equals reverse list L2. Now we've reversed both linked lists, hopefully. Let's see what we get here now. If I console this log out. So that's looking good. Both have been reversed. Okay, so now it's just the same logic as add numbers 2 the first time. We're just going to go from the left to right and then just add the numbers. So what I can do is make a remainder, set it to 0. Because recall, when you add two numbers, so like 4 plus 6, yes, the current digit is going to be a 0, but the remainder is going to be a 1, right? So that 1 is going to carry over, and then we need to do something with that 1. That's why I'm keeping track of the remainder. And then I'm going to make a while loop. I'll say while L1 rev, L2 rev exist. Should be like this. L2 rev or remainder. Essentially, I want this while loop to fire if there's anything left in L1 rev, if there's anything left in L2 rev, or if there's anything left in the remainder, because that means we need to create a new node. So we're going to create a new node each iteration of this list. So I'm going to say let dummy equal new list node. And I'm going to set it to just some arbitrary value. Doesn't matter what it is. This is just going to store our resulting linked list. Just like that. And as you may have guessed, we need a way to traverse our resulting linked list. So I'm going to say let tail equals dummy at the start. The reason I'm doing this is because if we don't make another variable to traverse the dummy list, then we're going to traverse the dummy list as we add to it. And at the end, we're going to have lost the reference to the pointer of the beginning of the dummy list. Okay. So with that said, now what do we do in here? Well, we know we need a sum for each addition. So like 3 plus 4 would equal 7. So our sum would equal 7. We also know that there may be a remainder from a previous addition that has been captured in the remainder variable. So I can just add that to my sum, just like that. Now we need to look at each list 1 rev and list 2 rev and make sure if there's something in there, we need to add it to our sum and then progress that node. because sometimes these linked lists are of different length. List 1 in this case has 4 nodes, so it's going to finish later than list 2, which only has 3 nodes. So we need to say if L1 rev exists, do something. If L2 rev exists, do something. So the something we're going to do inside each of these code blocks is just add the value of that particular list node into our sum and then progress our list node. So we'll say L1 rev sum plus equals L1 rev dot val. Now we need to progress L1 rev equals L1 rev dot next. Same logic here. Sum plus equals L2 rev dot val. L2 rev equals L2 rev dot next. We're just adding the value of that node into our sum, and then we're just progressing the node so we can continue onward. Okay, so if the sum created a remainder, like for these nodes, 4 plus 6 equals 10, the current value obviously is 0, but we need to make the remainder 1. So what we can do is say remainder equals math.floor of the sum divided by 10. And that's always going to return us that remainder value because we're using base 10 numbers. All right, so that's looking good. And then our sum also, we need to create a new node with that sum value in it. So we're going to say let node equal new list node sum, and then the pointer is going to be next, or null, sorry. So you might be wondering, well, like, we're going to put that whole sum in the list node. Well, what if the sum is that 10, or if it's a 13 or 23? That's obviously too large for the node. So instead of saying sum, we need to actually say sum modulo 10, and that's going to give us the proper value. If we did 23, the sum, or the current digit is going to equal 3, and then the remainder is going to equal 2. We get the remainder from here, and then we get the current digit from this logic right here. So that's how we're getting the appropriate numbers in their respective spots. All right, so that looks pretty good. Let's console.log the dummy. Oh, I actually need to add it to the dummy. Okay, so we're creating the node. Now we need to actually add it. So I need to say tail.next equals node. That's the node we're going to add. And then we need to progress the tail along. So I'll say tail equals tail.next. Now we should be able to console.log that dummy list we created as our result. And you can see we have our answer right there. We just need to get rid of this pesky 99, which was just a placeholder. That's pretty easy. We can just move the pointer over 1. So I'll say return dummy.next. Submit this. And why is it not working? Well, we have to actually reverse it back. Easy fix. Let's go back to the code here. We could say dummy.next reverse list and submit. And there's our answer. So the space complexity in this problem is going to be O of n because we are creating a new node for every node in list 1 and list 2, and then adding that to our resulting dummy list that we create and then return is our answer. The time complexity is also going to be O of n because the amount of operations we're performing by traversing the lists is proportional to the inputs. So to get this to work, we have to progress n amount of traversals. So in this case, we had 7 traversals we had to make, not including if there was a remainder. So that's going to be O of n for our time complexity. Okay, guys, just a quick solution. I hope you enjoyed the video. If you did, make sure to like and subscribe, and I will see you in the next one.